Welcome to the Future of Work, Integrating Emerging and Cross-Cutting Technologies. I'm your host for this webinar series, Mike Lasecki, and joining us today is Marilyn Barger and Richard Gilbert. Now let's look at the goals of this project. Focus on the first one. We want to empower community colleges to prepare technicians for the future. And look at the last one on the slide. Number 4, we want to foster implementation of the cross-disciplinary STEM core to maximize impact on technician education. Well, what does this mean? What's happening in the world of work? Well, certainly all of us know that the nature of work is changing at unprecedented speeds. And technology advancements, and you'll hear in detail about one of them today, in things like machine learning, AI, Internet of Things, and robotics are eliminating some jobs, but creating others. And technicians, the students in our programs who become technicians, sit at the center of much of this disruption. And we and education must keep up. And certainly our students' career paths will evolve. I like this term, future-proofing STEM technicians. In our project, we've identified 3 skill areas: data knowledge and analysis, advanced digital literacy, and business knowledge and processes. And by looking across these skill areas, we can integrate them in a cross-disciplinary way into the STEM core of our technical programs. And now let's hear from Marilyn Barger. Marilyn, personalize yourself to the audience and tell us a little bit about your role.
Well, good afternoon, everyone, or good day. I'm Marilyn Barger. I served as the co-PI, the PI of the NSF ATE Florida Advanced Technological Education Center for a number of years and now serve as its senior educational advisor. So I'm going to give you a little history of the work we did. Our center was focused on advanced manufacturing in the state of Florida. And early on, we were looking to, of course, work with industry to make sure the programs that supported manufacturing were as good as they could get and matched industry needs as best as they could. And we did this old time exercise of looking for common skills in a number of programs that were offered throughout the state that were related to advanced manufacturing. So there were programs in digital design. There were programs in drafting and design, advanced manufacturing, computer aided manufacturing, electronics technologies, etc. So we took about 6 of these and we pasted all of those state frameworks, which are standards and benchmarks for the programs that the colleges must observe, pasted them on the wall and highlighted common skills. So this is, exactly what we tried to do to consolidate the programs. And we were also looking for alignment to the MSSC Certified Production Technician Standard skill set for that certification, as at that point in time, around 2005-6, they were just emerging, as was the concept of integrating and aligning programs to industry certification. So what happened is we worked with the colleges, our industry partners, some community organizations, et cetera, and ended up defining a program that had really 3 components: the general education, what we ended up calling the ET technical core, and then 11 specialization at that time, sorry, 3 specializations when we started, that really took on the core of very specific technologies. So I just call your attention to the number 2, the ET core, technical core. These were cross-disciplinary skills. These are skills that we identified in all of those programs I previously mentioned, from electronics to advanced manufacturing to drafting, etc. So we were doing some cross-disciplinary skills back in the early 2000s and didn't really even know it. We certainly didn't call it cross-disciplinary skills at that time. But we were looking to increase enrollment, to provide multiple entry and exit options to meet our industry needs, of course, remove some duplication in teaching loads for the educators, and integrating industry credentials. So on this slide now, today we have over 2,000 students in over 20 colleges, starting with 3 back in 2008. And now we have 11 specializations with where we're moving now into Industry 4.0 with this advanced industrial automation. The name might change, but for now it's advanced industrial automation where we'll capture Industry 4.0 skills. It's yet to be approved and finalized. We're working on that right now.
Marilyn,
Again,
I had a question for you, Marilyn. Excuse me for introduction. These specialization tracks, are those tracks or are those courses?
these are all tracks. They're 24 to 27 credit hours, as it
Okay.
says at the top. And they all require that 18 credits of technical core,
Okay.
same technical core. So the students basically take one whole year of their program exactly the same, their gen ed and their ET core, and then they move into a track. Different colleges offer different combinations of these different tracks.
Okay.
Okay, so that's our first alignment to cross-disciplinary skills and identifying those. And as Mike has mentioned, and you look at the STEM core, you'll see some of these or all of these listed in one of those three buckets. So, fast forwarding to recent times with the emergence of Industry 4.0, we were funded to look at these skill sets and integrate them into our programs, especially advanced manufacturing. So the focus was on one or is on one of those specializations, and it's the most popular one that most colleges offer that particular specialization. All right, so we just looked at these lists of skills. There are many different visualizations of Industry 4.0 technologies. This was the one we used. We did a lot of work with our industry partners. We surveyed industry, we surveyed educators, we analyzed that data for gaps between the two groups. We then took the data to the two groups and coded it and worked with it. We also eventually aligned it to the existing framework to see how far off we were. So let's move forward. The result of those various iterations of just working with the skill sets from the surveys through the what we call caucuses, where we talked about them, we ended up with this list of 37 technical skills. They're not in any prioritized order, just to make this visually readable. You'll see many things that are in many existing programs, many skills people are already teaching. And what we discovered was 33 of these were covered in our programs already. So we had not too much work to do. And pulling out the ones that were not covered, we see database skills, data integrity, integrating systems, data interpretation, some interdisciplinary concepts, and security requirements. So, security requirements implying cybersecurity awareness. So, also, you'll see here, these are all in STEM core as well. They just currently aren't addressed in a big way in our program. So, this was what we decided to tackle and figuring out how to integrate them into the program. So we took that list, and as all of you might know or might not know, edge computing is also an advanced and emerging technology, and it's used to accumulate data from a variety of devices or equipment locally and to be analyzed locally before any of it is sent to the cloud for storage or whatever auditing, etc. So it's a nice way for companies that are doing things in real time to look at data, make adjustments at a faster time pace than they would if everything went to the cloud and had to be dealt with at that level. So it's commonly used in manufacturing and production environments. So now I'm going to turn it over to Dr. Gilbert, who's going to give us a little overview of how this works.
The Industry 4.0 technology insertion into the manufacturing workplace is placing new skill demands on the operation technology technicians that support this workspace. To support integration of the edge computing skills into Florida's Engineering Technology 2-year degree program, 4 community colleges developed an edge computer project using an industry-based edge interaction device. The LIMS box has manufacturing process sensors and final control elements and acts like an edge computing device that interacts with company-owned servers and does not have to interact with the public domain. This allows the company to interact with other equipment in the plant and have no fear of interference from the outside world or a cybersecurity break-in. The LIMS box has all of the software necessary to interact with your computer. This software will run all of the equipment as well as do calculations and graphics with information can be stored in mass storage devices of your choice. Please note that the company's local area network router has access to the cloud, and this is done when the company wishes to transfer information to the cloud. Several capstone student projects are also being developed. In this example, the independent variable frequency drives are not performing as expected. The OT technician is assigned to fix the problem. This is the graphic supplied to the students. It has all the information they need for the solution of this challenge.
So, Dr. Gilbert, let me ask you, Richard, let me ask you this question. Many of us are somewhat familiar with edge computing, but take a step back and what's the difference between OT and IT? You referred to an as an OT technician, and a lot of us know what IT is, but could you be specific? What's the difference between OT and IT?
Historically, I believe IT trained people would be involved in this only. The problem now, or the challenge now, is that in manufacturing facilities, it's usually operation technology technicians who are working the floor. And the IT person may not even exist there because they can't afford them, or the IT person is off doing other IT things. So it will be certainly the case that operation technology technicians are going to get involved with situations, perhaps in the middle of the night, where equipment doesn't seem to be working correctly. In this case, one of the independent variable frequency drives. So there is no IT person out there to go to. So we are going to have to put some of the IT skills into the OT person.
Well, that makes sense. So, in other words, they don't just wake up the IT person in the middle of the night and send them into the plant floor. That's not what they do.
Right. I think the important thing is the OT person, which is the term sort of new, I guess, or
Yeah.
not been used much, is really the manufacturing or production technician who's
Yes.
been operating equipment, and oftentimes just one piece of equipment at a time, and looking at data maybe from that piece of the operations, but not necessarily collecting it from multiple machines. So maybe things are running in parallel and they're trying to look at, are they working the same? You know, they're two lines doing the same thing. Maybe they want to compare those two lines, and edge computing would allow them to do that, to bring those two data streams together on the floor, and therefore the floor technician, manufacturing technician, operations tech would need to understand some of those communication skills of bringing the data from those two different lines to one place.
If you check with John Sands, for example, they are and he is very, very knowledgeable in IT and IT situations and cyber situations. He would tell you that what's happening is those three variable frequency drive equipment pieces were just replaced 2 or 3 years ago. And they aren't the simple, straightforward, single job task masters anymore. That equipment has multiple sensing, multiple interactions with multiple equipment. So the IT person won't know exactly which things are important relative to the problem. And it will take the IT person quite a while to go through all of the code to figure out what's going on when in fact something in the other part of the plant is working perfectly fine. So it is the Industry 4.0 new equipment that is driving the operation technology technician into this arena. he didn't have to do that, or she didn't have to do that in Industry 3.0.
Does that
Well,
help?
Marilyn, that brings us to a very interesting point. It's clear now that the skill sets of a manufacturing technician, let's call it an OT technician, as Richard just said, have to include things like networking and these other skills. Well, how do they get them? Do they take another class from the IT area, from the computer technology department at the college, or is it integrated in? How does that happen in an actual program like an engineering technology program?
So for us, it happens within the program itself. It may happen to we do a lot of project-based learning in our
Mhm.
programs in Florida. So that's one way. So Richard mentioned the kind of case studies and senior projects or capstone
Yeah.
projects that students were some students were developing and others would be using as one place where they would integrate this. But I know a lot of the faculty are starting to integrate the networking piece into their PLC courses,
Uh,
especially those that have programs that have two PLC courses, like the beginning and intermediate kind of course, that they would do that networking piece right within that second course. Or the robotics course if it's after the PLC course. So there's lots of ways that the amount of information that they really need is just, to keep the facility running and their equipment running. So they need to understand how they communicate, but they don't need to know everything else. That if it becomes turns into a network problem, the IT people are going to have to come and fix
yeah,
it.
sure, sure.
So it turns out that one of the colleges, and it happens to be in Palm Beach, is involved directly in building some of these applications for us. And their program is in biomedical
Uh,
technology. It isn't even manufacturing. So she has already integrated these concepts into her program because she has the same problem. If there's a new piece of biotech equipment, it's going to be driven by the extra freebies, if you like, that come with Industry 4.0 new equipment. So her technician students have to be prepared to deal with that as well. And she does not do manufacturing per se in her biomedical program.
Let me follow up with you, Richard. So a program then ideally would have some sort of edge computing device that a student could get some practical hands-on experience with. I
That's
mean, do
correct.
these things cost $500, $5,000? How
Yes,
does one?
that's a very good point. The actual one that we got, because we got it through engineering, we got it through a grant source, was a industry-based piece of equipment, and it
Uh-huh.
was, I'll,
5 grand.
I'll just quote 5,000, that's not
Okay.
correct. However, we are also working on with colleges and part of this project to do a Raspberry Pi and or
Arduino.
right, so smaller, inexpensive machines that would not be used directly in industry, but can be used in a college environment, and those prices are under 1,000. The actual CPUs are, don't quote me at the grocery store, but the actual CPUs are $100 to $200, and then the other equipment, depending how exaggerated you want to make your point, could be up to $1,000. So
Okay. So there's some options. Marilyn, I'm a faculty member and I'm just sort of vaguely, I'm a manufacturing person. I know about networking. I'm not all that solid in it. And I'm a little intimidated by thinking about bringing something like this into my program. How do I skill up? How do I get myself up to speed, my own professional development? How do Florida faculty do it?
Well, in Florida, we have a great community of practice. It's called the Engineering Technology Forum, and that's a vehicle for professional development for us. We meet twice a year and gather that kind of information, what people need, and hook people together, connect people who knows this and who knows that with those who don't. So, for example, we just had a 2-day, well, we had an all semester workshop that culminating with the 2 days of PLCs with some networking actually
Mm.
in this last Monday and Tuesday at one of the colleges that hosted and also instructed the other faculty. A small group of 6, I believe, were in attendance and one presenting. So that's how we're taking care of ourselves. And otherwise, I would say to reach out into the greater NSF ATE community. I'm sure
Yes.
there'll be some new resources and workshops coming out of that. Our plate is actually hoping to develop the Raspberry Pi idea, which we have a pilot of that's worked into a workshop that will illustrate the skills and then provide this educational affordable platform for them for educators across the country to use. But we might be 8 months out from getting that into a workshop kind of area. I've got to work on more data collection. That's where we are right now, but we've got the hardware working.
So the engineering technology programs around the country, and there's over 200 of them, are organizing themselves to be to support the Engineering Technology Center. And with that in mind, it is likely that we will have a professional development workshop at High Tech in next year, 2000, well, sorry, this is 2024. So we are looking, this is a national situation, so we're looking to make sure that there's national opportunities for professional development.
Well, good. Thank you, Richard. Richard and Marilyn and myself, let's work together and put together some show notes with the resources that we have now that we can share with people. So thank you. And thank you both for this, because it's such an example of I'll use this term in a tongue-in-cheek manner, using such a cutting-edge technology as an example of integrating cross-disciplinary skills. You mentioned the implications of cybersecurity. That's one of the drivers of this. And Richard, you mentioned Dr. Sands. He is also producing a webinar in this series on cybersecurity implications, and I'll make sure that we cross-link to that one as well. As we wrap up today, I'd like to remind you again of our project website, preparingtechnicians, all one word, .org, and the tools and resources that you will find there. These include the white paper, a framework for a cross-disciplinary STEM core. You can download and share cross-disciplinary instructional cards in your class. You can listen to podcasts, or you can share these recorded webinars. Here's some examples of those cross-disciplinary instructional cards. They're organized in those 3 major skill areas. You can see things in the middle, for example, under advanced digital literacy, like network communications, Internet of Things. We heard about that today. Automation, robotics, network architecture. So these are small learning activities that you can bring right into your classroom. Also podcasts, for example, episode 37, Incorporating the Internet Things, talks about how to take cross-disciplinary technology and integrate it into a manufacturing area. And finally, recordings of this webinar series are available at preparingtechnicians.org/webinars. Thank you again for joining us today.